All right, so this is the Algebra Review Day 3. We're going to start with exponential properties. All right, so if you look here, we're multiplying. So what we're going to do is we're going to multiply the coefficients. 2 times 5 is 10. Also look that there's no exponents on the outside here. They're exponents of 1, so we don't have to worry about them. Then if you look, you have x cubed, and it's times an x. So we have x cubed times x to the first, which is x to the fourth. We have y to the first times y to the fourth, which is y to the fifth. And there's your final answer. All right, so if you notice, we used a property here. The reason that it's to the fourth and not to the third, we didn't multiply our exponents, we added our exponents, is because x cubed is x times x times x. X to the first is just x, so if you look, this is all still multiplication, it's x to the fourth. Same thing with the y's, this is y times y times y times y times one more y, so this is y times itself 5 times y to the fifth, okay? So the property is that if you have a term and it's raised to a power, let's say a, and it's times, and it has the same base there, so x and x, and this has another number as an exponent here, so let's say b. What you're going to do is you're going to keep the base and you add your exponents. Okay? All right, so let's move on to the next one here. We have some division going on. So if this wasn't here, we know how to simplify that. That's a third because 3 goes in here once, 3 goes in here 3 times. All right, so now we have an x in the numerator and the denominator. The rule is you can only have them in one place, the numerator or the denominator. That way you know it's simplified. So first thing we have to say is that you can't have negative exponents, which we don't right now, okay? But like I said, you don't want them in both places. So we can look at it as subtraction when you're dividing. So if you had x to the a over x to the b, x to the b, you can keep the base and subtract your exponents. But notice if I do 3 minus 8, I'm going to get a negative exponent, which brings us to another problem. So instead, the way I like to do it is I look at it and I say, I can't have them both places. Where is there more? They get to stay. The other ones have to go. So I'm going to say, okay, where's there more? The denominator. Those are going to stay. I'm going to get rid of the 3 up here, take away 3 from the bottom, and I have x to the fifth in the denominator. I'm going to do the y's the same way. I have 2 down here, 6 up top, so I'm going to get rid of the 2 down here, take away 2 from here, you have 4 left. But also notice 6 minus 2 is 4, so you could have subtracted them. Write your final answer. I have a coefficient of 1, which you do not need to write. So I'm just going to write the y to the fourth. The 1 is implied. I have a 3 coefficient in the denominator, x to the fifth. Notice in my final answer, there's only x's in the denominator and y's in the numerator. They're not in both places. All right, moving on to the next one. It's very similar to the one above, but the difference is that it has this square out here. So I have to square this, this inside this parentheses right here. So what I want to do is I want to go through and think about multiplying something by itself. I have to do 3 times 3, x to the fourth times x to the fourth, y to the fifth times y to the fifth, z to the 0 times z to the 0. But let's start with that z to the 0. We have a rule that if you have x to the 0 power, that's equal to 1. The reason being is because think about having x to the fourth over x to the fourth. 4 minus 4 is 0, so that's the same thing as x to the 0. But what's anything divided by itself? 1, all right? So that's why you got to think of it that way, okay? All right, so since this is 1, I'm just going to cross it off and say that's times 1 right there instead of times 0. And now I'm going to go ahead and multiply everything by itself. 3 times 3 is 9, or I could have just done 3 squared. X to the fourth times x to the fourth is x to the eighth, okay? Y to the fifth times y to the fifth is y to the 10th. So if you look at the shortcut to doing that, if I have a power raised to a power, or a power raised to a power, you can multiply the exponents. 4 times 2 is 8, 5 times 2 is 10. And then here we have times, there is just an exponent of 1 here, so I don't have to worry about squaring or cubing anything. 2xy cubed. Now this isn't your final answer because you still have multiple x's, multiple y's, and 2 coefficients, and we don't want that. So we're going to clean up the coefficients. 9 times 2 is 18. X to the 8th times x to the 1st is x to the 9th. And then y to the 10th times y cubed is y to the 13th. All right, last but not least, we have another fraction which looks similar to the one above. It's, division. I'm going to do the coefficients first. 2 goes in here once, 2 goes in here 5 times. This time I see negative exponents, and you're not allowed to have negative exponents. So here's an equivalency that you should know. X to the negative a power is equivalent to 1 over x to the positive a power. So what we're going to do is we're going to drop the term to the denominator and make the exponent positive. Similarly, if you had, let's say, x to the negative a over y to the negative b, I can't have a negative exponent, so this has got to go to the denominator, and the exponent turns positive. And I can't have a negative exponent in the denominator, so I got to bring it up here, and that turns positive. All right, so first thing I notice is I have negative exponents here, and I don't like it. So I'm going to say, okay, this x to the negative third is going to come down to the denominator and become x to the positive third. I'm going to do the same thing with my y's. Please realize there's more than one way to do this, but this is the way I like it the most. I'm going to put a y squared up here, put a y to the 6th down here. All right, now I got to clean this up. I'm not done yet because I see that I still have y to the 8th and y cubed down here, so that's y to the 11th. And then I have y's both in my numerator and my denominator. Sorry, those were x's, the first one. My y's I do have to clean up. There's 2 here. I'm going to get rid of those. Say there's 4 left. So now I can put my final answer. I have 5 over x to the 11th, y to the 4th. There's my final answer. Okay. Ooh. Okay. All right. So now we are going to move on to the next set, which is rational expressions. Rational expressions is just a fancy way of saying a fraction. So what we're doing in this first set here is just simplifying the fraction. We already know how to simplify fractions, but let's talk through like some 3rd grade math here. So let's say you had 5 over 10, 5 tenths. If I said simplify that fraction, hopefully you're like 1/2, right? And you just know by looking, like you have that, like you can do that in your head, right? But I want to teach it to you the way that you were actually first taught it, that seeing that it was so long ago, you probably forgot. So what your teacher did is she had you do, or he had you do, the prime factorization of both the numerator and the denominator. So break it up into its factors that are prime. So 10 would be 2 times 5, and 5 is just 5, okay? Now these are both times 1, right? But 1's not a prime number. So please realize there's also a factor of 1 in all of them. It's just not prime, okay? Now what you do is you simplify by saying that you can simplify any common factor from numerator to denominator to 1. Because notice you have a 5 over 5 here. And the reason I can simplify this to 1 is because this is multiplication, okay? It's a factor. So 5 divided by 5 is 1. And now if you look, you have 1/2, right? All right, so we're going to do the same thing here. We can simplify by, a lot of people say canceling out to 1, okay? So we need common factors that cancel out to 1, which really means they simplify to 1. So right now, this is not factored at all. So let's go ahead and factor it. We're going to factor the numerator, factor the denominator. Numerator, we're looking for 2 numbers that multiply to give us -2 and add to give us -1. That's -2 times 1. Divide by a, which is 1. So you have x minus 2 times x plus 1. The denominator is a difference of squares. So that factors to x plus 2, x minus 2. And now we can simplify any common factors. I see I have a factor of x minus 2 and a factor of x minus 2. Remember, there's multiplication right here, so those are factors. Now my final answer, x plus 1 over x plus 2. Okay, no, the x's do not cancel out. They are not factors. There's addition separating these two, so this is a factor of x plus 1, and this is a factor of x plus 2. All right, moving on to the next one. We're going to go ahead and factor this so we can simplify it. The numerator has 2 terms. The first thing we look for is a GCF, and it doesn't have a GCF, and it's 2 terms. So the only other thing it can be is a difference of squares or a difference of cubes or a sum of cubes, which it's not, x minus 3. The denominator does have a GCF of 5, and you got another x minus 3. So there's a factor of x minus 3 in the numerator and the denominator. They cancel. Remember, there's that multiplier of 1 up there, so this simplifies to 1/5. All right, next section is multiplying or dividing. This is done very, very similarly. To multiply these, what we're going to want to do is we want to simplify it by factoring everything and then canceling out any common factors, or simplifying any common factors in the numerator and denominator to 1. So let's just go factor crazy. The numerator has a GCF, right? Always check for a GCF first. Anytime you're, say, not factorable, first look for GCF. 2 comes out, you have x minus 3 as another factor. Is 8x factorable? A lot of times people say no, but technically it is. It's just that I wouldn't factor it. It factors to 2 times 2 times 2 times x, right? But you don't need to do that. So I'm just going to keep it as an 8 because I know how to simplify without doing that, okay? All right, we have times, and now you're going to factor the other 2 things you need to factor, polynomials. All right, so the numerator, at first people might say, like, not factorable. Wait, is there a GCF? Yes, there is. There's a GCF of x, and then you have x plus 1. Denominator has 3 terms. There's no GCF. I'm going to make my organizational x. 2 numbers that multiply to give me -3 and add to give me -2 are -3 and 1. Divide by a, so you have x minus 3 times x plus 1. All right, now what we're looking to do is to simplify this. It's 2 fractions being multiplied, so it's just technically, if I wanted to make this crazy, I could multiply the numerator, multiply the denominator, but we're trying to simplify here. So please realize that you can cancel out anything that's common from the numerator to the denominator. Doesn't matter which fraction it's in. X minus 3, x minus 3, x plus 1, x plus 1. Now, this is a factor of x, right, because this is multiplication. This is also a factor of x because this is multiplication, so those can cancel. Then I have a 2 over 8. 2 goes in here once, 2 goes in here 4 times, so the final answer is 1/4. They're not always that beautiful, okay? We worked really hard to make that pretty. All right, next we have division, which we know that we cannot divide fractions. So what we do instead is we multiply by the reciprocal. So you leave this first fraction the same, you change it to multiplication, and then you take the reciprocal of the second fraction, okay? So first fraction we're gonna keep the same, but we're gonna factor it because we wanna simplify. So the first one, the numerator is a difference of squares, x plus 3, x minus 3. And then the numerator, the denominator, I'm gonna use my organizational x here. And then in the top of this, I'm gonna put a times c. A is 2, c is 3, so that's 6. B is 7. I'm looking for 2 numbers that multiply to give me 6 and add to give me 7, which are 6 and 1. I'm gonna divide by a, which is 2. Notice 6 over 2 is simplifiable to 3 over 1, and then I'm gonna go bottoms up. This is x plus 3, and this is 2x plus 1. All right, now I'm going to do times instead of divided by. I'm going to factor the numerator. I'm going to write it in the denominator, right? So here I'm looking for 2 numbers that multiply to give me a times c is -15, b is 2. So that is 5 times -3, divide by 1. Bottoms up, x plus 5 times x minus 3. All right, now I got to factor 4x plus 20. Please don't say it's not factorable. Look for a GCF. There's a GCF of 4. And then I have x plus 5 as a factor also. All right, so now we're going to look to simplify this. We're looking for common factors. X plus 5 and x plus 5. X minus 3 and x minus 3. Oh, x plus 3 and x plus 3. And that's it. So we're going to write what we have as our final answer. 4 over 2x plus 1. Oops, and there you go. Okay, once again, you can't go any farther because this is a factor, okay? All right, next we have adding and subtracting rationals. So as a reminder, in order to add 2 fractions, so like if I have 1/3 plus 2/7, 2/7. In order to add these 2 fractions, we need a common denominator. And you wanna find the least common denominator because then it's easier to simplify when you're done. So the least common denominator is 21. So I would need to multiply this by 7 over 7. I would need to multiply this by 3 over 3. I know my denominator would be 21. And then 7 times 1 is 7, plus 2 times 3 is 6. And then you add these and you get 13 over 21. If it's simplifiable, then you would still simplify it. All right, we're going to do the same sort of situation here. Okay, so we are going to start by getting the lowest common denominator. Okay, if the denominators aren't factored, you will need to factor them in order to find the least common denominator. X minus 2 is not factorable, nor is x, so they are both factors. We are going to need an x to cover the x, and we're going to need an x minus 2 to cover the x minus 2. So that's our LCD. All right, so now what we're going to do is I like to now write my new fraction, x times x minus 2 is my new denominator. And now I'm going to get my numerators. So I'm going to do that by getting my common denominator. So this already has an x minus 2. It still needs the x. I need to multiply the numerator by that too. This already has the x. It needs the x minus 2. And I'm going to multiply the numerator by x minus 2. Now I'm going to write my new numerator. So I have 4 times x, which is 4x, the plus sign. And then I have 2 times the quantity of x minus 2, but I'm going to go ahead and already distribute this. So that's 2x minus 4. All right, the only thing left to do here is to combine like terms. So I have 6x minus 4 over x times x minus 2. Now before I box this answer, remember this section up here started off with just simplifying, right? When we have a fraction answer, we got to make sure it's simplified. So we have to make sure this is simplified. In order to make sure it's simplified, we have to see if it's completely factored. The denominator is completely factored, but the numerator is not. There is a GCF of 2, and if I factor that out, that's 3x minus 2 over x times x minus 2. Well, there's no common factors, so it's not simplifiable. So either one of these answers is okay. I would just stick with your original. All right, next one right here, okay? I first need to find the LCD. In order to find the LCD, the denominators have to be completely factored. So let's go ahead and factor this denominator here. I need 2 numbers that multiply to give me 6 and add to give me 5, which are 3 and 2. And then divide by a, which is 1. So this becomes, bottoms up, x plus 3 times x plus 2. Difference of squares, x plus 3 times x minus 3. All right, so now let's find our LCD. We're going to need an x plus 3, which will be covered in both of these. So I have the x plus 3 that'll cover one of each. I need an x plus 2, and then I need an x minus 3. So there's your LCD. All right, I'm going to copy this, copy, and paste this right here, because this is my denominator. All right, so now I'm going to get my numerators. So this is missing the x minus 2. The first one is missing x minus 2. So I'm going to do x minus 2. And an x minus 2 to multiply this by. The second denominator is missing, what, did I mess up? Yes, I did. This is supposed to be a 3. That was right. This is right. This was supposed to be a 3. I accidentally wrote a 2. It's a 3. So an x plus 3 and an x plus 3, that's this. An x plus 2, which is this, and the x minus 3, which is this. Much better. Okay, so this is missing, it has an x plus 3, an x minus 3. It's missing the x plus 2. And now I got to go back and check the first fraction. Okay, so it had the x plus 3, it had the x plus 2. It's missing an x minus 3. There is no x minus 2. But notice I found my mistake. Okay, all right, so now let's clean up the numerator. This is my new numerator, okay? I could just write this down, but I'm going to automatically distribute it. So 3x times x is 3x squared. 3x times negative 3 is negative 9x. And then I'm going to make sure I don't just distribute a 2 here because it's minus 2, so I'm going to distribute a negative 2. It's negative 2x and negative 4. Combine like terms. I see like terms right here. I'm going to combine those. So I have 3x squared minus 11x minus 4 all over, and I'm going to paste my denominator again, but I'm going to fix that minus 2 to a minus 3 that I accidentally copied down wrong. And now, lastly, I have to see if it's still simplifiable. So to see if it's simplifiable, I have to see if any common factors cancel out. The denominator is already factored. The numerator is not. So I'm going to look for a GCF. There is no GCF. It's 3 terms, so I'm going to use my organizational X to try to factor it. So I need 2 numbers that multiply a times to give me a times c, which is negative 12, and add to give me b, which is negative 11. Negative 12 times 1, and then divide by 3. This is a 3x plus 1. And this simplifies to negative 4 over 1, so this is an x minus 4. And after that, good practice it doesn't simplify. So you can either do this over this as your final answer, or you can just do this as your final answer. All right, that's the new stuff for today. The rest of this is practice with solving. So what I suggest you do is pause the video and try these 5 on your own, and then just fast forward through it to check your answers. And if you got something wrong, you can look through the work and see what you did wrong. But if you got them right, then you can start on the homework. All right, I'm going to go ahead and solve this. It's higher than a quadratic, so I know I need to factor it. In order to factor it, it has to be equal to 0, which it is. So I'm going to start by looking for a GCF, x squared plus 2x minus 24 equals 0. All right, so this is still factorable. So I need two numbers that multiply to give me negative 24, and you had to give me 2, 6 and negative 4. Divide by the a value, which is 1. And now I have that x factor, and then x plus 6 times x minus 4 equals 0. All right, now remember, this is an equation that you're solving, so you need to tell me what the solutions are. So you're going to set each factor that has an x in it equal to 0 and solve for x. So we have x equals 0. If I set x plus 6 equal to 0, I get x equals negative 6. If I set x minus 4 equal to 0, I get x equals 4. So 3 solutions. All right, moving on to the next one. It's a quadratic. So the first thing I say, can I solve it by square rooting? Nope, there's an x squared and an x. So I'm going to try factoring. First thing I always look for is a GCF. There is a GCF. Set each factor with an x in it equal to 0 and solve. So solving this, divide both sides by 2, you get x equals 0. Solving the second one, you get x equals 7, and you have 0 and 7 as your two answers. All right, next one. Can I solve by square rooting? Because this is quadratic. I do not see an x squared and an x, so the answer is yes. I want to get this by itself so I can square root it. So I'm going to subtract 5 from both sides first. Sorry, subtract 9 from both sides first. I have x minus 3 quantity squared equals negative 4, and now I can solve by square rooting. Square root. Don't forget to account for both the positive and negative solution when you square root. X minus 3 equals plus or minus. So I say, okay, I see negative underneath the square root, so I know I is in the answer. And then do I know the square root of 4? Yes, it is. It's 2. So plus or minus 2i. All right, x is still not by itself, so I'm going to add 3 to both sides. X equals, remember when writing your answer, this goes first, which is 3, plus or minus 2i. This cannot be simplified anymore. If it was 3 plus 2, you could do 3 plus 2 and 3 minus 2. But it's 3 plus 2i, which I don't know what 3 plus 2i is, and I don't know what 3 minus 2i is. It is what it is, so you just leave your answer like that. All right, moving on to the next one. Can't square root. Going to try to factor. Two numbers that multiply to give me 4 and add to give me negative 1. Nope. So I got to use the quadratic formula. All right, so we have x equals the opposite of b. b is negative 1, so I'm going to do positive 1. Plus or minus the square root of b is negative 1 squared minus 4 times a is 1 times c, which is 4, all over 2 times a, which is 1. All right, let's clean this up. We have x equals 1 plus or minus the square root of negative 1 squared is 1. Negative 4 times 1 times positive 4 is negative 16. All over 2 times 1 is 2. Clean this up. X equals 1 plus or minus the square root of negative 15 all over 2. X equals, all right, so now we got to simplify the square root of negative 15. All right, so first I'll start with the negative. So I know I is going to be in the answer, right? So I'm going to be like, all right, I is going to be in my answer. So I have 1 plus or minus. I know I is going to be in my answer, okay? And then I have square root of 15 left, right? So can root 15 be simplified? Is there a perfect square that goes in there? So I have 4, 9, 16 is too high. 9 is not a factor, 4 is not a factor. So it's not simplifiable, so I'm just going to leave root 15 there. The I does not go underneath the radical, Okay, it goes in front, or you can put it behind. You can write it like this, root 15. Make sure you put that little mark right there because it tells you that the I is not underneath that. Okay, all over 2. Now we're going to look to see if these 3 numbers are simplifiable by the simplify by the same thing, and they aren't. So this is my final answer. All done. All right, moving on to the last one. Can I solve it by square rooting? Yes, there's just an x squared. So I'm going to get x squared by itself, subtract 4. X squared equals negative 18. And now square root to solve. Square root plus or minus, square root plus or minus. X equals, don't forget your plus or minus, always write that down first. All right, now I'm going to simplify the squared in negative 18. I know y is in the answer, so I'm going to write it down again. Okay, but root 18 is simplifiable. The perfect square of 9, 16 doesn't, but 9 does. 9 goes in there 2 times. So it's root 9, root 2. Root 9 is 3. So there's a 3i, and then your root 2. Okay. All right, there's no, x is already by itself, so this one is all done. All right, you can go ahead and get started on your homework.